Okay, I'm going to do this recording a little bit differently without the PowerPoints because I didn't have enough room to do some of the equations on it. So I wanted to kind of review a little bit on 8.2, and this starts on page 208 in your book. Okay. But compounding is referring to compounded formulas or compound formulas. So compounding, of course, is that process of using raw ingredients and or other prepared ingredients to prepare a drug product for a patient. So this is going to be similar to making a cake from scratch by using ingredients such as butter, sugar, eggs, flour, and baking powder. So you're going to need a specific amount of each one to make your cake. So it's kind of the same concept. A formula, of course, is a written document prepared by the pharmacist that lists the ingredients and instructions needed to prepare a compound. So anytime you have a compounded product that you need to compound together, it will be written on a formula sheet that you will need to follow. So some formulas are going to be intended to prepare a single prescription, and others are going to be intended to prepare a compounded stock solution. Okay, or a large amount to be divided for individual prescription orders for later. Okay, so what I'm going to do is go through um, your problem sets. The examples are in there, and I feel everybody can go through these examples to kind of give an idea. But now I wanted to go through a couple of the problem sets to give you an idea of what you should be doing. So with your problem set on 8.2, this is going to be on page 210, and this we're going to do number 1 first. Okay, so you are going to fill the following order by preparing 2 bags of 500 milliliters of admixture from your stock solutions of lidocaine, which is 20%, and your furosemide, 10 milligrams per milliliter. State how much ingredient you should add to the 2 bags. Okay, so what we're going to do is it pretty much boils down to doing 2 ratio and proportion questions. So I've had a couple of students tell me they didn't know kind of where to put the numbers at when dealing with word problems. So what I do first when you're reading a word problem is you want to go ahead and just write out. When you do let me back up a little bit. When you do a ratio proportion problem, and this is just an example, and we'll go to the next slide to actually do or erase it. Uh, on this side, the fraction is going to be the prescription, and I'm going to abbreviate it with RX. On the other side, and it don't matter which side you put it on, but the other fraction is going to be what you have in stock. Okay, and since for number 1, if you read number 1 again on page 210, you're of course preparing 2 bags of 500 milliliters of admixture, and then if you look below, you have the prescription. Well, the prescription says 1,000 milliliters of Distrix 5 in water, 5% water. So we have the 1,000 milliliters, and what they're doing is you're going to take that into 2 500 milliliter bags. So that's splitting that 1,000 milliliters up into 2 500 milliliter bags. Okay. So what I do first usually helps me. Let me erase what's on here. Is I will write out, if I get stumped on a problem, I will write out. Of course, you know, you have the 2 bags of 500 admixture, so that means you need to split everything up. Okay, in stock, in your question, it tells you what you have in stock. So your lidocaine, I'm just writing this out just to kind of pull it out of the word problem and just put it by itself. 20%, and you have your furosemide, 10 milligrams per milliliter. Remember when it says per, it just milliliters, it means 1. Okay, so and then you're going to make 500, oops, 2 500 milliliter bags. Okay, but what you want to do first, do the first ratio. You're going to do lidocaine first, and then we'll do a ratio proportion for the furosemide. Okay, so for the RX, if you look at, we'll do the lidocaine first. Okay, it says lidocaine in the RX 2.5 grams. So for the RX side, and we want to divide it in half because this prescription is for 1,000 milliliters, but we're going to do it 500 milliliters for 2 bags. So you want to half everything. So lidocaine, half of 2.5 is 1.5 grams. We're trying to find X milliliters for that prescription. Okay. On the other side is going to be your stock. So our stock for lidocaine and lidocaine. Okay, it's 20%. So remember 20 would be grams. So you have 20% grams, and percentage always means 100 milliliters. Okay, we have the grams are the same and milliliters are the same. So we're finished with that one. We just got to cross multiply. X times 20 is 20, goes on the bottom, and 100 times 1.25 would be 125. So it would come out to be 6.25 milliliters of your lidocaine per bag. Because remember, you need to divide that up to, we divided this up to 2, so it's per bag. Okay, so now we want to do the furosemide. I'll just abbreviate it FUR. So we're going to do the same thing. We know our stock will be on this side. Okay, so we're going to do 1 milliliters into 10 milligrams. Okay, so that's our stock. In your prescription, you have 500 milligrams, but remember you're halving it. So it'll be 250 milligrams of furosemide in X milliliters. Okay, so we have weights on the bottom. Both of them are in milligrams, so we're good, and milliliters on top. So cross multiply. Anytime you multiply, the X by always goes on the bottom. And 250 times 1 would be 250. If you mark out your zeros, 25 over 1 is 25. So you have 25 milliliters of furosemide per bag. Okay, so that is showing you an example for number 1. Now, what may be confusing to you with these questions is in 8.2 is they're all going to be a little bit different. When you're working with word problems, you pretty much, sometimes I have to read the question over a couple of times. So you want to read through it, then you want to read through it and say, okay, what am I wanting? Okay, then go back up and you read it again. Well, how can I figure that out, what I want versus what they're giving me? So you kind of have to do that a few times. And some people panic after they read through it one time. They don't understand what they're supposed to do. But it takes me, even myself, who is used to doing word problems, you have to read through it several times and think about what they are actually asking for. Because they can get you and confuse you on some of the details sometimes. So here, number 2, we'll do it. Again, it is on page 210. Okay, so on this one, you want to fill the following order and prepare enough admixture for a 24-hour period. How much of each ingredient will you need to bring into the IV room? Potassium chloride comes packaged as 2 milliequivalents per milliliters in 15 milliliter vials. Okay, so what you need to do here is you're trying to figure out what are they asking. Okay, so what they're asking is potassium. If you look at your prescription, you have 1,000 milliliters of normal saline with 20 milliequivalents of potassium chloride, and you're going to infuse it at 125 milliliters per hour. Okay, so you need to know how much of each ingredient you will need to bring that into the IV room. Okay, so first I just kind of write out, what I have in stock. So potassium, and I will abbreviate it, sorry, chloride, stock. This is what we're going to have in stock. You're going to have 2 milliequivalents per 1 milliliters, and they come in 15 milliliter vials. Okay. If you look at the prescription, you're going to be infusing it at 125 milliliters per hour, and you need enough for a 24-hour period. So you need to figure out, you take the 125 milliliters, you need to find out how many milliliters you need for 24 hours. So if there's 125 milliliters per 1 hour, you would need to times that by 24 hours. Okay, so 125 times 24 would be 3,000. milliliters is what you would need in 24 hours time. Okay. Um, if and so if you look at your Rx, the Rx is coming in 20 milliequivalent potassium chloride in 1,000 milliliters per bag. So you would your 20 milliequivalents. If you had 3 bags of 1,000, okay, because it comes in 1,000 milliliters. Your prescription is what they're wanting it in is 1,000 milliliter per bag, and you need 3,000. So what you would need to do is you would need 3 of those to equal 3,000 milliliters. Okay, so that's why how we come up with the number 3, multiply it 3 times. So 20 times 3 would be 60 milliequivalent potassium concentration. Okay, so the Rx, and that's how we got the number for our Rx. So you have X milliliters over 60 milliequivalents. And we got the 60 milliequivalents from, uh, how much you need in 24 hours and how much is they're wanting it to come in 1,000 milliliter bags. So then you're going to equal it with what you have in stock, which remember was your 1 milliliters per 2 milliequivalent. Okay, so then you're just going to cross multiply. X times 2 is 2, goes on the bottom. 60 times 1 is 60. 60 divided by 2 would be 30 milliliters of potassium total. Okay, but they come in 15 milliliters per vial, so you would need 2 vials. Okay, let me do another one here because they all are a little bit differently. Number 3 is a little bit easier, and I'm doing a few of them to show you that each one of these word problems, you can use ratio proportion most of the time, but then sometimes it's just asking you something for a little bit more simple. So if you look at number 3, and this again is on page 210, you are to prepare a 30-gram jar of ointment using the following formula. State how much of each ingredient you will need. So with this one, of course, you have if you look at the prescription, the coal tar is 4 grams. Okay, you have your salicylic acid is going to be 1 gram. Your triamcinolone, and I'm abbreviating, is going to be 15 grams. And your aqua base ointment is going to be in 100 grams. Okay, so it's what they prescription they want it for. They want coal tar 4 grams, salicylic acid 1 gram, triamcinolone 15 grams, and aqua base ointment 100 grams. So this is going to yield 120 grams. Okay, but if you look up in your question, you are to prepare 30-gram jars of ointments using the following formula. State how many of each ingredient you will need for each small jar. So if you notice, all these added up together is 120 grams, but you need it in 30 milligram jars. So all you have to do is you take 120 and you divide it by 30, and you get number 4. That number 4 tells you how many times. It's just like cutting a recipe down. Like if you was making a cake and you only wanted to make half the cake, you would cut it in half. Well, this one you cut it in 4, so you're just going to divide it by 4. So 4 divided by 4 would be 1 gram. 1 divided by 4 is going to be 0.25 grams. 15 divided by 4 would be 3.75 grams. And 100 divided by 4 would be 25 grams. So this is how much of each ingredient you would need to fill it in 30-gram jars. Okay. Number 4 is very similar to that one. but you're kind of doing the opposite. Instead of dividing, you're having to multiply. But you use the following formula to prepare 150 vaginal suppositories. How much of each ingredient should you weigh out? So uh, the stock is going to yield, if you look at the prescription here, you have I'm going to abbreviate progesterone 2.4 grams. Your polyglycol 3350 is going to yield 30 grams, and then you have the polyethylene glycol 1000 is going to be 90 grams, and all that together is going to make 30 vaginal suppositories. Okay, so it yields 30. Okay, vaginal suppositories. So you need 150. So if you take 30 and you want to get 150, what would you do? You would multiply it by what number it gives you to give 150. So 30 times 5 would be 150. So because that's how many suppositories. The formula to using the following formula to prepare 150 vaginal suppositories, but the formula only yields 30. So you just multiply everything by 5 to get 150. So 2.4 times 5 would equal 12 grams, or 2.4. 30 divided by 5 would be 150 grams. And 90 times 5 would be 450 grams. So you need 450 of the polyethylene 1000, 150 grams of the polyethylene glycol 3350, and you'll need 12 grams of your progesterone, okay, to make, that's how much you need of each one to make 150 suppositories. Okay. So those are some 4 examples out of Chapter 8.2. If you have any questions, just send me an email. I'll be glad to throw up some more practice problems and post them online for you. Or we can meet live on Blackboard Collaborate either way.